We'll look at just a quick example up here, and then we'll start to kind of skip around on that. So once again, we're not doing all of them, but we'll get a good idea of how to do them in the next video day. So this is called function operations. Let me see if I can get a nicer marker here. I like fresh markers. It's not quite fresh enough for me. Let's see what we got. Oh, okay. So function operations, I believe in the book, I do get my notes out of the book, so I don't necessarily use it a lot in class, but that's where I'm getting this stuff from. You can sign out a book. I keep meaning to do that. We'll take a few minutes one class if you would like one, or you can just ask. But this is section 6.6. I'll always try to attach this section, so if you do ever want to go back and refer to it, I'm more than welcome to. So operations, we think about adding, subtracting, multiplying, and dividing. So we want to be able to do all those things with functions. So I'm just going to show you kind of the basic setup of them. Right now it'll mean not that much, but we'll write it so we can refer back to it, and then we'll actually look at some examples. So basically what we're saying is we want to take two functions and add them together to start. So if I had the f of x function and the g of x function, if I wanted to add them, that's what it would look like. All that means is I'm taking the f of x function and I'm adding the g of x function. So that's just kind of a fancy way to write it. I always like to write it this way. It makes more sense in my head. You'll see that in a minute with some examples. But for now, we'll just do kind of the basics. So we can also subtract, which just means in this case, we would do f of x minus g of x. We can multiply. Kind of get the idea, just how to split them up. And you can also divide. We're also going to do something in a few minutes called composition. So you might want to leave a little bit of room for yourself, but we'll add that in later. Excuse me. So let's see, what the heck are we actually doing? So we're going to be given two functions, and we're going to try to combine them using whatever operation is given. So let me show you what the actual examples might look like. So if we're given these two functions, I'm going to say f of x is 3x minus 2. And g of x is x squared plus 1. We're going to do some evaluating, so some plugging in. So using those as examples, if I said, hey, what is f plus g of x? But now we actually have to define what they mean. So I like to rewrite it. This just makes more sense to me. As f of x plus g of x, because then I can now go back and kind of relate them right to my functions. F of x, I'm just going to replace with 3x minus 2. G of x, I'm going to replace with x squared plus 1. And then my main goal is to just take those two things and add them together. So it's just kind of getting past how it's set up and how we relate that back to what we were given. In this case, we're just really combining like terms. I do ask that when you combine like terms and given final answer, it is in standard form. Standard form means your highest exponent should be first. So I'm going to put x squared out in front. It goes down in order, so my x would be next. And then in this case, I can combine my constants. Negative 2 plus 1 would give me negative 1. And if I asked you, if I added f of x and g of x together, what would I get? That would be your answer. So you're not just getting like a number. You could get an expression. That's perfectly fine. Excuse me. But that is how you add. Just combine. So there's a few little things you just want to pay attention to. If you did f minus g of x, looks very similar, except now we're subtracting instead of adding. I like to just remind myself that's just f of x minus g of x. And now I can just plug in my functions. F of x is 3x minus 2. G of x is x squared plus 1. Here's where you need to be careful with subtraction. You are subtracting this entire function. You have to put parentheses there. You can't just subtract the x squared, that's only part of the function. So when you see subtraction, just make sure you do have parentheses. And you're subtracting the whole thing. I like to just distribute those, the negative, excuse me. I get negative x squared minus 1. And then I'll combine like terms and put things in standard form. So that would be negative x squared plus 3x. And I can combine those to get minus 3. So very similar, just little things like your signs will mess you up though. And then let's just look at number 3 quick. That's going to be f times g of x, which is just f of x times g of x. Another room here. So in this case, I'm going to multiply 3x minus 2 times x squared plus 1. I like to use those parentheses. That kind of reminds me of my distributing from back in the day. So this is all algebraic stuff we're doing. So now that I'm multiplying 2 binomials, I'm going to distribute. So I just take this first term and distribute it over. That will give me 3x to the third. Remember, when you multiply, you do add exponents. And then I'll distribute here. That will give me plus 3x. Now I'm going to distribute my second term. I get minus 2x squared minus 2. And please make sure final answer should be in standard form. That would give me 3x cubed minus 2x squared plus 3x minus 2. And that would be your final answer. We are not going to be dividing today. It's kind of a big pain in the butt. We do a lot of dividing later in the year when we do rational expressions. So we will save the division, unless it's like super simple with just like some numbers, for later. So let's do a little practice with these just to make sure we're okay with the general operation stuff. And then we'll add in that composition part, which is a little bit different. So can you please, now that we've had a few examples in our notebook, just grab out that little packet. I'm just going to kind of skip around. So once again, some we'll do together. Whatever we don't do together, you'll be finishing Thursday. Excuse me. And I'm sorry because it's kind of annoyingly numbered. Like for the first section, the numbers go down, and the second section they go across, and that's going to drive me nuts. But we'll just go with it. We'll just do our best. So the first section really just focuses on function notation, which we've already have a little bit of an understanding from just with piecewise functions. We talked about function notation. I just wanted to make sure. We were okay. Hold on, let me go. So let's like do the most basic one. The most basic one's number 1, just to make sure we have a good example here. If I said f of negative 3, we're semi-familiar with this. In the f function, we're plugging in negative 3. So I take that function and plug in negative 3 for x and then simplify. Okay, so that's really just telling me what I'm plugging in. That would give me negative 13. Okay. That wasn't bad. There's some other ones you're just plugging numbers in, same idea. Just make sure you plug it into the right function is the big thing. So then we get to one, I'm just kind of skipping around here, like number 8. Sorry about the numbering, just find 8. It says h, but now instead of just throwing in a number, constant, we're throwing in an expression of x plus 4. So this is where more of the algebra comes in. So just as a reminder what we're doing, we're taking the h function. I'm just going to write it right above just to remind myself what it is. So the h function is 8 minus 3x. And we're saying instead of x, we're going to plug in x plus 4. So on this side, instead of x, we're going to replace it with x plus 4. Since it's an expression, you should always put it in parentheses. Okay? So in my h function, anytime I see an x in the original, I'm replacing it with x plus 4. So on this side where I see an x, I'm replacing it with x plus 4. Then you just do as much simplifying as you can. We hopefully see that we can distribute here. That gives me 8 minus 3x minus 12. And then in standard form, when I combine, that would be what? Negative 3x minus 4. So same idea, it's just now, instead of just throwing numbers in places, we do need to get used to having some algebraic expressions as well. So let's do one more in that section. I'm gonna kind of start it with you and then I'm gonna have you finish it, just to see if you're remembering some of that fun stuff from years past. So I'm gonna look at number 9. And you'll see why 9 is a little bit trickier, even though it kind of looks the same. Okay, so it looks very similar to 8. We have a function that we're plugging into and we're plugging in an expression, okay? I'm just gonna remind myself right above what the actual function is. So P of x is x squared minus 2x, just as a reminder. So I'm telling myself, okay, anytime I see an x, I'm gonna replace it with 5x minus 3. So on this side, I'm gonna replace this with 5x minus 3. I'm gonna square it. And then I have minus 2, and that x also gets replaced with 5x minus 3. Always use parentheses when you're plugging it back in. So this one is going to have a little bit more simplifying than the other one did, because we have to square that binomial. Sorry, too much talking today. So a reminder of squaring a binomial, do not just do 5x squared and 3 squared. You need to multiply 5x minus 3 times itself. That's what squaring means. And then we still have that second part where we're going to distribute in the 2. So you're going to have to do this in a few steps. First step, you would distribute for these 2 binomials to see what you got. Second step, you would distribute into that third binomial. And then you would combine as much as possible. So I'm going to give you a minute or two just to get that algebra flowing through your veins again. And see if I asked you to simplify that, could you do so? Or can you just see how far you can get? I'll give you a minute or 2, or 3. And then we'll just skip around a little more, try a few more examples, and then quickly look at composition. Because we only have only 15 minutes. Let's do attendance, what you guys are doing. Another minute, can you get the simplified answer? Ooh, Lordy, what did I do? Give me one more second here. Sorry. Attendance is now like a 12-step process. As joyous as that is. All right, awesome. So let's look and see if you were okay with that, if you have any questions. So just bringing back those algebra skills, because we're gonna need them this year. If you haven't noticed, I know this is called Geometry Algebra 2, but we're kind of starting with the Algebra 2 portion. And we do geometry later in the year. We actually last year didn't do any geometry because of COVID, and that was sad. So it probably is the end of term 3. So it'll be a while. If you like geometry, you can wait. If you don't like geometry, there you go. So I got 25x squared. When I distribute the next one, I would get negative 15x and minus 15x, so that would give me negative 30x plus 9. Over here, I'll distribute. I'll get minus 10x plus 6. I'll combine like terms, making sure I'm in standard form, and I will get 25x squared minus 40x plus 15. You can leave it like that. Some people saw, hey, there was a GCF and they took it out. You don't have to do that for now, but you're more than welcome to if you like. Any problems with simplifying that? Okay, so if you forgot something, I feel you. For now, just write it down, and then as we're practicing, if you see any other questions, you let me know. So those were just kind of we weren't really combining anything. We were dealing with one function. We were just making sure we're getting comfortable plugging in some algebraic stuff as well. So now let's look at some functions. We'll just do 2 or 3 of these, and I just want to do something quick with compositions. And that will be it for today. Time flies here. Short classes. So that little second section says function operations. You can see we're either adding, subtracting, or multiplying. Once again, there's no dividing. It's a big pain in the butt unless you have nice numbers. So we kind of showed mercy on you there. So kind of the most basic one is one like number 10. I like to do a basic one and then build on it. So if it's at h plus g of 3, I like to rewrite it. It just makes more sense in my brain. I write it as h of 3 plus g of 3. So those were those kind of original rules we wrote at the beginning. Because I can visualize this. Oh, h of 3. Okay, in the h function, I'm going to plug in 3. I'm just going to do that right in my head. Where is h? Did I do this one before? I'm going to lose my mind. No, okay. Sorry, that would be 8 minus 3 times 3. So 8 minus 9 is negative 1. So without too much trouble, I could get that. I can find g of 3. So g function, that would be 2 times 3 squared plus 5. Just remember order of operations. You would do 3 squared first. That's what 9 times 2 is 18, plus 5 is 23. And then once I simplify both of those, I just remind myself I'm telling you to add them. So once you've added them, that would be your final answer. So it's really just getting comfortable kind of splitting things up. Remember, for addition, it doesn't really matter, but for subtraction, if I said h plus g of 3, minus 3, h minus g of 3, and then I said g minus h of 3, they're different things. So order does matter. So that's why I kind of like to rewrite it. It makes a little bit more sense to my brain ski. But let's look at one that has a variable instead of a number. Then we're going to try one, and then we'll just look at one other quick thing. Nothing too crazy. So I'm going to go, let's do 15. I'm just picking random ones here. Just flopping around. So it looks pretty similar to 10. In this case, we're subtracting instead of adding. The difference is instead of being a number there is just a variable. So I like to rewrite it. I would rewrite this as f of x minus h of x. I kind of like to split it up and have them as their individual functions, because then I can just look them up. F of x, I can't really do anything to. I'm not plugging in. I'm just looking and saying, what is f of x? Well, f of x is 3x minus 4. Then once again, h of x, I can't really do anything. I'm not plugging anything in, so I just look it up. H of x is 8 minus 3x. Just be careful, once again, especially with subtraction. When I'm subtracting the entire function. So always use those parentheses. Just to remind yourself, it's not just the first term, it's every term. So I like to do a little simplifying. So we have 3x minus 4. I just distribute that negative in. So I get minus 8 plus 3x. And now I can combine my terms pretty easily. What would that give me? 6x minus 12. If you saw there was a GCF and you want to take it out, go for it. You don't have to though. So just so you see, sometimes you'll throw numbers in like number 10. Sometimes it'll just be a variable. So you're just kind of looking at your functions and then trying to combine them as much as possible. So before we do this last part, which is on the back, why don't you guys try 1? Why don't you try number, you guys are going to try 17. So if I asked you, what is G times P of X? Can you try to figure out what that would be? If you need help, you let me know. I'll come help. Well, I'll help you from a distance, but I'll still help you. Always ask questions, especially since you know that graded problem set's coming up. You will see problems similar to these. So I'll give you about 1 more minute. I'm just going to start to kind of set mine up. So that would be G of X times P of X. And this would be 2x squared plus 5. So once I kind of set it up like that, I noticed, okay, we're just doing G of X times P of X. I just find their functions and kind of rewrite them. I like to put the parentheses around just to remind myself this is a distributing problem. So I'm going to, you can distribute however you please. I'll start with this first one. Remember to add the exponent. So that would give me, I don't know what I'm writing for. That would give me 2x to the 4th. When I distribute over there, that would give me minus 4x to the 3rd. And then I'm going to distribute this 5. I get plus 5x squared. And then minus 10x. And that would be your final answer. So just be careful, little things like adding exponents. It may have been a while, but that's stuff we want to remind ourselves of. Does anyone have a question with the few that we tried on the front there? So there's just one more thing I wanted to show you quick because it will give us a good lead into tomorrow. And then we only see each other 2 days, so it's stuff we want to get started. So we have one more thing. You can, I don't really care where you write this, so I'm going to write the kind of general. It's called the composition of functions. If you want to put that back in your notes with kind of your other operations, I don't really care how you organize yourself. So it looks like this. So when someone said like, oh, that fog problem, that's not an O. This means F is being composed with G. It's just, it looks like an open circle. So that still means a whole bunch of nothing. So we rewrite it like this. We say F of G of X. And what we'll do, and it makes a little more sense when you do it with an actual problem, so I'll do it with you in a second with a problem. It means you kind of work from the inside out. So you take at g of x, and you take whatever's on the inside, and then you plug it into f of x. So I'm gonna find like the most basic one, just to kind of understand the concept, and then we'll work our way up tomorrow as we are adding stuff in. So let me just flip that little worksheet paper we were working on, and I'll find one for us. That's it, we don't want to start with a crazy one, because that will be all sorts of funky. So I'm gonna start, I'm like even skipping, we're gonna skip to 22, okay? So I'm gonna show you the idea, and then we'll kind of go back and do it with some of the other stuff later. 22 says f of g of -3. I believe we are, like, we're using the functions right at the top of that direction, so you don't have to flip back to the front. I think they switched the f of g, that's fine. So what this means is, we work from the inside out. For the g function, we're gonna plug in -3 and figure out what the answer is. Then, once I have the answer to that, I'm gonna plug it into the f function. So this is how I set it up. I like to organize, I'm an organizer. I start from the inside, and I'm gonna start with g of -3. And I can do that, okay, that's not too overwhelming, one thing at a time. And the g function, plug in -3, so I'm using those directions right above it. So that would just be what, 3 times -3? Which comes out to -9. Okay, that wasn't terrible. So now, I have another step. I've done g of -3. What I do is I take this answer, and I'm gonna plug it into the f function. So I always kind of go this. This answer is gonna go into the f function. So you work your way out, you do g of -3 first, find the answer, and then the answer to this goes in the f function. So in those directions, it would be 2 times, we're gonna throw in -9, minus 1. That would give me -18 minus 1, so my final answer would be -19. So a composition, when we compose, we work from the inside out. So we figure out what that, or we evaluate what it is, whether it's a number or a variable, and then we take the answer to that and plug it into the outside. So let's try one more, because then that'll interrupt us, so we'll be fine. So let's do 24. That will be our last one today, and then we'll work more with compositions tomorrow. Okay, so if I was saying that out loud, I would say g of h of 24. I like to rewrite it like this, g of h of 24. So what I do is start on the inside. We'll always start in, work our way out, and I'm gonna figure out what h of 24 is. What is h of 24? What is h? Oh, 24 squared plus 1. You can use a calculator. I think it's 577. I just have my answer there from before. Once again, you don't need to do that stuff in your head.
576.
Yeah, 576.
But you have
Plus the
one? Yeah, okay. You add the 1, so now, composition means I'm gonna take my answer to the inside part, and I'm going to plug that answer into the outside part. And I'm gonna now do g of 577. You kind of work your way out. G of, what's g here? 3 times 577. So now I would you could just throw that in your calculator, and your final answer should come out to be 17 of 3001. So the main goal, compositions, you're composing, you're kind of putting some functions together, you're working from the inside out. We'll practice more of that tomorrow, because there will be some ones where we're just using x's, or we're using expressions.
At this time, all seniors are dismissed. All seniors are dismissed.
So that's that. So for now, we're kind of plugging along with this. We'll do some more tomorrow, but keep it in handy because we will be working on that.